Hi, I'm Betty D, and in this video we're going to look at how to find the area of a circle. Okay, so I'm going to remind everyone that from our previous videos we were looking at modifying the formula for the area of a rectangle and the fact that that can be used to find the area of any shape. Okay, and that's going to include circles as well. Remember, the key part to this is we need two dimensions that are perpendicular or at right angles to each other, okay, or make a 90-degree angle to each other. So, if we have a look at a circle, I'm just going to draw a little bit of a grid here. Okay. It's not real good. We'll fix it up a little bit. Okay, so we have a circle here. There's a little bit of terminology we need to make sure that we understand about circles. Okay. Firstly, we have a property of a circle, which is that if we look at our centre, the distance from our centre, the outside of our circle, anywhere on the outside of our circle, that distance is called the radius. Right? And we're going to use R to represent it. So we say radius, right, is our R. And that's our distance from the centre to the outside of our circle. Now we also have our diameter, okay, which is the distance all the way across our circle that goes through the centre. Okay, and we call that letter D for diameter, and it's also equal to 2 times our radius. Okay, since our radius goes from the centre to the outside and our diameter goes all the way across to the centre, we can see our diameter is 2 radiuses. Okay, and last little bit of terminology is circumference. Okay, now circumference is just our fancy word for the perimeter of a circle. Right? It's just our fancy name for the perimeter of a circle. It's called circumference, and we use the letter C for that. Okay, so that's our sort of definitions that we need for a circle. Right? Now we can get into actually how to find the area of a circle. So, what we're going to do, right, is similar to triangles actually, where we're going to surround the circle, okay, with a rectangle, or in this case, it's a square, all the way around it. Right? And we're just going to have a look just at 1/4 of the circle to start off with. Just 1/4. So we'll look at this here. And we can see for that square, okay, it's got dimensions of 3 centimetres by 3 centimetres. Okay, so we can see then that this green square has an area equal to 9 centimetres squared. Okay, that's for this green square up here. Now we can also see though that the dimensions of that square is actually our radius times our radius. Okay, radius and radius. So we can actually say that that's the same as our R, our radius, times our radius. And whenever we have a number times by itself, we can write it as a power of 2. So we can say, we read that as R squared. Okay, and it's literally because we've got the same length here. When we multiply together, we get the area of a square. That's why we call it R squared, or if you like, 3 squared. Okay, so we've got that so far. Right, so we've got this area of this square. Now we're going to have a look at the area of just 1/4 of the circle. Okay, just 1/4 of the circle here. Okay, and what we're going to do is we're just going to look at trying to count the squares. Okay, because remember that's all we're doing with areas. We're always just counting squares. Now I can see I've got 1, 2, 3, 4 squares that are full, but then I've got some part ones. Okay, this one's not quite full. This one's not quite full. Okay, but I could take a bit off these. Okay, I could take a little bit off this and put it over here. I could probably take a little bit off this one and put it over here. Okay, and count that as square 5 and square 6. Okay, and I reckon I've got a bit more than half left over. Okay, I reckon I've got a bit more than half left over. So I'm going to say overall that this square adds about another 1 1/4 squares. Okay, so these two together are going to give me another 1.25 squares. So overall I have 1, 2, 3, 4, 5, 6, 7.5. I'm going to say my area there is 7.5 centimetres squared. Now we can see that now remember though, we don't want to count up squares all the time. That's inefficient. Okay, that's inefficient. So what we want to do is go, okay, well how can I utilise this square up here to get the area of my circle? Well, I know that if I look at 4 of these squares, they make up the big square. And that big square is clearly more than what the circle is, because we've got all these extra bits here. So I don't need 4 lots of them. Okay? Oh, well, do I need 3 lots of them? Do I need 3 of these squares to make up that circle? Yeah, well, maybe. Not sure. Okay, well, sorry, that should be 7.25. So let's have a little think here and go, well, what can we do? What can we do? Actually, I'll make this simple. Let's just call that an extra 1 square. Make our maths a little nicer. So we'll say half each. All up, it gives it 1. So we'll just say our area is 7 square centimetres. Okay. That'll make it a little nicer. So what we're going to do is go, okay, well, all up, I was saying my circle then has an area of 28 centimetres squared, because that's 1, 2, 3, 4 lots of 7 gives us 28 centimetres squared. Okay, well, I know the area of my green square was 9 centimetres squared, so if we want to work out how many we need, what we can do is say, well, what is 28 divided by 9? What is that? Because they'll tell me how many I need. When we do that, we find that we get 3.11 and so on. Okay, so this would tell us that we need a bit over 3 of these squares up here, these big green squares, to form the area of our circle. Now the thing is though, you can see that I wasn't particularly accurate with this. Okay, I even changed it a couple of times. Like, it was easy to count these 4 squares because they were whole squares, but then I had to start doing cutting off bits. I changed this around a little bit, okay, and I'd said that it was 1.25, and then I changed my mind and said, let's just make it 1 instead, okay, and that's the problem. Now, we could do this more accurately if these squares were smaller. So if I had smaller grid paper, I get more accurate because I have more squares of the whole ones, okay, and less of the part ones, okay, so I'm going to be more accurate when I match them up. If I go smaller again, I'm going to get more accurate. And smaller again, I'm going to get more accurate. And what that's going to do is make this number more and more accurate. And if we did this lots of times, with lots of different people, right, and average out all their results, we're going to get a number that is around about 3.14159, and this number actually keeps going on and on and on. Okay? And we actually find that that number has a special name, okay? And that number is called pi. Okay? It's a Greek letter, pi. You've probably heard of it before. Okay? Hopefully you've seen it before. Okay? But it's actually 3.14159, and like some people know lots of digits on it. It's an irrational number, so it goes on forever. But what it tells us then, okay, is how many of these squares up here we need to fill up our circle, right? Which is important because we can actually form a little equation here and say, well, our area is equal to the area of this square. Now, in this case, it was 9, but remember we said that it could be, we can think of it as our radius times our radius, okay, which is r squared. Okay, so we know that area is r squared, and we know we need to multiply it by this value of pi. So we say pi r squared. Right? I think it's worth doing another example for this. Sorry, and I won't go through the whole process of it. Right? But we're saying here's a circle with a radius of 2 centimeters. Okay? We want to know the area. Well, we can use this formula and say, well, the area equals pi, which is at 3.14159. And don't get me wrong, this is a calculated question. 8 times our radius squared. Remember, our radius squared means the radius times the radius, so that is 2 squared. Okay, so that's going to give us a value, okay, of around about 12.56 centimeters squared. Okay, often we might use an approximation of pi, which is 3.14. Okay, all your calculators are going to have a button with a symbol for pi on it. Okay, so you can be a little bit more precise. But that's all we do. We take this radius measurement, okay, we square it, which means we times it by itself, okay, and times it by pi, and it's going to give us the area of a circle. Okay, incredibly useful. And you'll find that this number pi comes up in all sorts of areas of maths. So hopefully that's enough to get you through working with circles.